All right, so here we are, people. Remember, this is an alternative to checking your answers using the answer keys. You can simply do that. Go to GMS Learn, click on your math videos, and to the far left, you can get your answer sheet, bring it up and check it. The idea behind the video here is if you need more than what was there, you've got this opportunity. So we left off with question number 5. So, the thing that we want to notice in question number 5 is that it is a triangle. So, we've got something like this. And even though it's not a right triangle, the same technique's going to work. So, if you go ahead and you draw it, we can make it into one large rectangle. And then what you'll end up seeing is, if I drop down to the middle here, that it is half of this top rectangle. And again, it is half of this bottom rectangle. So the idea is that we can find out how wide it is, which we can count. So I'm over there, 1, 2, 3, 4, 5, 6. We figure out how tall it is, 1, 2, 3, 4. We can again multiply. 6 times 4 is 24, but we only want half of it, so we're going to divide by 2, so we get an area of 12. So again, we can still make it into the rectangle. We can still find the area of the rectangle and chop it in half. When you look on over at your next problem that you're dealing with, this is can you name it? Can you? It's one of my favorite shapes to say, just the way it sounds. Parallelogram. I like to emphasize the L's that are there. With your parallelogram, this is one where we saw yesterday. If you look up at question number 4, it also is a parallelogram. So what we can really do is simply cut and move. So we've got something that looks like this. If we go ahead and cut this triangle off, and then we slide it right over there, we're going to get that rectangle that we've got. So all we really need to do is figure out how wide it is and figure out how tall it is. So if I come on over here, remember we did slash here to bring this on over. When we count, a little bit easier to see it from the top here that it's 1, 2, 3, 4, 5, 6. So again, it is 6 up there. If we counted from down here, we would start here because again, we did cut there. 1, 2, 3, 4, 5. And then because we moved it over, it would make a 6 that is there. So again, either way, it's the same thing. And then how tall is it? So 1, 2, and we have a 3 that we're looking at. So again, it was made into a rectangle. So it ends up becoming 6 times 3, which gives us 18. So again, the more visual we can be with these particular problems, I think the easier they're going to be here at the start for you to get that understanding of what we are dealing with. So next page here, question number 7, just a rectangle. So when you look at your particular rectangle, you can just simply count how wide it is, 1, 2, 3. All right, count how tall it is, 1, 2, 3, 4, 5, 6. 6 times 3, hello, 18. All right. Question number 8 that we're looking at, this is a trapezoid. And what we're actually going to have to do here is we are going to have to go ahead and cut it up into our 2 shapes. So we can do that and then realize that it's 3 wide, it's 2 tall, so we have an area of 6. And then again, we can notice it's a triangle there. So again, we can find the area that it's 2 wide and 2 tall. So 2 times 2 is 4, but chop it in half, so we get an area of 2. So 6 plus 2 would give us 8. We can also simply remember area is just the number of squares. And this one works out really nice because the triangles are cut perfectly in half. So we can just count 1, 2, 3, 4, 5, 6, 7, and then a half make a whole. So there we are. We've got ourselves with 8 up on that we are dealing with. So again, if they are crisp and clean like that, then we can certainly end up making use out of it. Um, Question number 9 is going to do the exact same thing, where the visual aspect is going to help you out tremendously because we can just count. So you can see there's 1, 2, 3, 4 of them. And then we've got 1, 2, 3, 4, 5, 6, 7, 8 halves. So if we've got 8, but they're all worth a half, that's a grand total of 4. So we do get a total of 8, so that works. The other thing we could do is we could take this square and actually chop it on up. And what we'll notice here is that we have 4 right triangles. You could actually take this guy and put him right up in there. Take this guy, put him right up in here, and you're going to get yourself a rectangle that you're dealing with. So again, working from the visual standpoint, it's another alternative that you're dealing with. So by moving that on up there, we can see it's too tall. By moving this up on there, we can see it's 1, 2, 3, 4 wide. 4 times 2, yeah, that also gives us 8. So again, it's an option that we're dealing with here. All right, so 2 more here. Question number 11, we do want to notice that it is a triangle. So because it's our triangle, we could once again see if they're cut perfectly in half. And well, they are, so we can do that. But that's a lot of counting that we're dealing with. So I think this might be a better idea where we end up taking our shape, cutting it and moving it. So if we slice it right down the middle, we can take it and put it right there, and we're going to form that rectangle that we're dealing with right there, right there, right there, and right there. So if we kind of count, we see it's 1, 2, 3, 4 high. All right. And if we count the width, 1, 2, 3, it is 4. 4 times 4 gives us our 16. So we can definitely do that. You could also count all the halves that are there, because they're crisp, clean halves you're dealing with. And the very last one here, 2 options here. One, we could just count them up because again, they are crisp, they are clean halves that we have there. So we can see there's 1, 2, 3, 4 of them. 2 halves makes a whole. So now we're at 5. 2 halves makes a whole. So we're at 6. So that's certainly going to work. Or we could chop. We could move and place it right there. So now when we're looking at that rectangle that we've made here, so if we count how tall it is, 1, 2, all right, we count how wide it is, 1, 2, 3, or if we went down from there, 1, 2, 3, because remember we did move it on over, 2 times 3 gives us 6. So again, emphasis on this lesson number 1 is your visual. We can cut and move pieces to make them into rectangles. Triangles, we can cut them and take half of it as half of a rectangle, or we can just simply count if they make nice, crisp, clean. So lots of methods when we're on the grid. It's just kind of which one do you see the best? And my goodness, people, I skipped question 10. My goodness. Oh my goodness. Let's take care of that one here. All right. In question number 10, it is a parallelogram. So we might think about how we can kind of cut and move it. We could do that. I don't see a crisp, clean cut and move though when I'm looking at it. So I think because it's got nice halves to work off of, that's exactly what I'm going to end up using here. So if we kind of get the sketch of all of them that are kind of going through there, and I know it's not going to be absolutely perfect there, but we can get this pretty good. All right. Well, maybe not. All right. I tried, people. I tried. Let me erase that out of here. Let's get those in between there. I think we're just going to count here. So you can see 1, 2, 3 holes. All right. Then when we look at our halves, 1, 2, 3, 4, 5, 6 halves. So if we have 6 halves, that's another 3 in total there. So grand total of 6 there. A half and a half does make a whole. So yeah, area of 6. So again, if you've got questions, certainly I'll be having those office hours set up. If there's something that between the answer key didn't work for you, the video with the notes, with the classwork kind of talked through didn't work for you, definitely take care of that for you. All right, take care, guys.